Hello, welcome to part two of this Eve Microsoft Excel case study that I am going through. So we have finished levels 1 through 3 about building ships and the cost of the ships. Now we're gonna kind of readjust our frame of mind in order to start on level 4. And what we're given here is that we have a cell address for C6, right? And we need the total market of minerals stored on that asteroid. So essentially what we really want, what this question is asking is, given a cell address, so C6, I want us to go to this asteroid map, identify C6, figure out what type of asteroid this is and what the number inside it is. And then based off of that and this asteroid table, identify how much of minerals is in that asteroid, right? So the first thing we note that we need is just this asteroid table. So once again, we're gonna put that into our reference just to make it easy for us in the future. But now I think the main issue here is what's the best way to identify the address of these cells? And once again, we're only given a background color, right? For the asteroid. So I think once again, the best way to go about doing this is to utilize what we did similar with the ships and pull the background color of these asteroids. And then like kind of taking a look at the case study, it seems like in the future we're going to be given a lot more asteroids here too, right? So I think what we just want to do is we want to just output kind of all of these asteroids, their background colors, and then their values in kind of a nice lookup table format, just so we can reference in the future. So the first things first, let's grab these background colors. And once again, we'll just reuse some of our Excel code. So we have rows 40 through 43, right? So for row 40 to row 43, we don't need the columns this time because it's just essentially column 15 or something like that. I think, let me just double check. We want column 15, yes, and the results to be spelled out in column 16. So the background color is equal to cells row 15 and then 16 to be spit out. We'll save that, we'll run that. We got the background colors of these asteroids, and we are going to once again put them into our reference sheet. Okay, now the interesting part. How are we going to pull out all of the asteroids on this asteroid field map? So essentially what I want is a reference sheet with like C6 as an asteroid, C9 as an asteroid, C12 as an asteroid, and so forth. So the easiest way to do that is we're just going to do a simple if statement. So if this cell is greater than 0, then we're going to return the address of that cell. Otherwise, we'll just return NA or return no here. And so we're going to essentially do that for every single one of these cells and every single one of that. And so essentially what that looks like there is 9 rows, I think. Yes. Oh, sorry, 9 columns. Yep. Okay. And essentially what that looks like is this. So we have now a table where we have all of the values that we care about being populated. here. So now we just need to extract these non-n values. And the easiest way to do that is just using a unique formula. Because a bunch of these are not unique, right? So we're just gonna do a unique on kind of these rows. And then we're just gonna pull across. Cool. And so now we have kind of all of our unique values here and the n values that we don't care about. So we're just gonna copy and paste these as values, and we wanna just combine them all into one row. I'm pretty sure, or one column. I'm pretty sure there's an easier way, but this isn't a huge data set, and it's just easier for me to just copy faster to copy and paste it like this. Cool. So now we have the value of everything on the grid that's important here. We can essentially think of anything else as just zeros or things that aren't important. In order to, like, these have these annoying dollar signs, so we're just going to clean up the data a little. So we're going to do substitute this text with the dollar sign as nothing. And so now we just get a really nice list of asteroids here. So we're going to, once again, create in the reference table asteroid location. Okay, so now what we need is, you can imagine we want the background color of these asteroids so that we can populate the asteroid type, right? Once we have like the asteroid type, we can reference kind of or use kind of that location. Where were we? Yeah, use this location essentially to pull all of the information that we need about kind of the asteroid type and the like amount of materials that's contained here. So how we're gonna go about doing that is, once again, we're gonna utilize some Excel. So we're gonna go into our sheet 1 reference here, and we're gonna try to reuse as much of our code as we can. And now we just want to pull the asteroid color. Oh, the other thing I just realized we also need is asteroid count. So we want to pull the number of the asteroid. And since we're getting the background color already, it's just easy to get the number as well within the same macro here. So let's see, what do we need to loop through? We need to loop through rows 2 through 26. So we loop through rows 2 through 26. And then so the trick here is that, let's grab the column first. The column is W, whatever that corresponds to, 23. Okay, so essentially we have this cells row and 23 ends up being this asteroid location. So you can think about that as the range. So range. Okay, so essentially now we have a range for kind of the cell that we want, right? Because this cell's row 23 dot value is essentially like, for example, C6. So in this case, we get the range as C6. And then we want the interior color of that cell, except it's on a different worksheet, right? Because right now we're in the reference worksheet. So we want to change that to the asteroid field map worksheet. We're just going to copy the name here. Right? Uh-oh. We need a space. Okay, we need it to be like that. Okay. So now we got the range, interior, the color, and then we want to spit that out onto row 24, right? So row 24 of our sheet is the background color. And then we want the asteroid count, which is so cells row 26 dot value is equal to this whole thing dot value. I think that should be it. And we'll just save it and we'll just run this. And let's see if it did what we did. Yeah, awesome. So no, this is our starting barge, that random R square. So we're not really concerned about kind of this F10, but it doesn't really matter. We can just leave it. We have the background color and we have the asteroid count. So now we just end up populating the type of asteroid here. So equals X lookup. Once again, this is really simple. Lookup on this column and this asteroid, and we'll just keep everything static. And we got C6 is Veldspar, and all of these asteroid types down. So now let's grab the amount of minerals. We might as well, right? Grab the amount of minerals for this particular square in these asteroids. So this would just be another lookup. Veldspar, that, and we can populate 0 as anything that doesn't exist. Cool. So now we got Veldspar has 400, 0, 0. And as we populate down, we just get all of our minerals for each of asteroids. Now that we have built out our reference, we can much more easily solve the rest of these case studies. So for level 4, we just have the cell address here. Now, what's the total market value of the minerals on a certain specific date? So once again, we just need to figure out the total amount of minerals required or that is existing within kind of that asteroid. So what we can do is we can pull out the minerals here. So this would be the minerals in this particular asteroid. And so in order to calculate the minerals in an asteroid, what we need to do is we need to pull, for example, X lookup this asteroid. And we want the tritanium. But we also need to multiply it by the asteroid count. So X look up this address. This, and then multiply it by 1000, right? Because this count is indicates how many thousands. Actually, honestly, it might just be easier for me in here to directly calculate based off of the asteroid, but it's just a little bit nicer to keep these separate just for organizational purposes. So we want to keep this lookup dynamic, this static, this static, this static. We don't need the case because that's that. This static, z static. Cool. So that should get us all of the minerals required from each of these asteroids here. And note, there's going to be some NA values because these don't actually contain asteroids. So that's totally fine. It's expected in our output here. And then finally, what we need to do is we need to figure out the market value of the minerals. So now that we have the minerals in each asteroids, we need to grab the price of the minerals as of November. So let's just go with date. So that's 11/27/2023. And we're just going to drag this down because technically it's the same date. So now we need mineral prices. And remember our previous bit of kind of programming where we have the titanium, pyrite, Mexilon, and isogen prices. We're just gonna reuse our formula here. So ideally, when we copy it, it should be the same prices on November 27th. Yep. So 425, 10, 12, let's double check. 425, 10, 12, 52, 52. Yeah. So these are the right prices here. We're just going to drag it down. And then we have the total final value. And so this will just be a sum product. Again, there's definitely kind of a repetition of this of different themes of kind of formulas that keep on getting reused. And that should be there. And then finally, we need to report in millions of ISK, right? So final answer would be round this divided by 1 million to 0, 10. And that is exactly what the answer for the example is. We do want to turn all of the NAs to zeros though. So what we want is if error 0. There we go. And then we just copy and paste this across. Correct. Nice. So now we have 620 points and on to level 5. So level 5 is we're provided with a sequence of asteroids mined by the player on an asteroid map. So now we have a bunch of asteroids to mine, and we also have mining skills. And essentially, there's 3 kind of complexity layers here. So we have more asteroids to mine, we have mining skills, and we have a barge that can only take up to a certain amount of cubic meters. How much can the barge bring home, right? So once again, what's important here is let's figure out. So eventually what we want is like a total number of the 4 minerals that we get. And then once again, we can do a sum product with the price on November 27th. However, in order to get the total minerals, first we need to figure out how much the barge can bring home. And in order to figure out how much the barge can bring home, we need to figure out, based off the mining scale, how much can be mined from each of these asteroids. So we're going to start with not the mining sequence, but asteroid type, right? Because this is really, once again, easy, but we're just going to do it in step by step. Equals X lookup. We'll figure out this asteroid type by just identifying this, we'll keep this static, that dynamic. So that should pull all of the asteroid types down. So now we have a table of the asteroid types here. However, the tricky part here now is we want essentially the mining skills of that particular asteroid based off of this column, right? So what we end up doing here is asteroid mining skill. Once again, we pull this over. And what we need to do here is we need to use an index lookup in order to figure out kind of, we're going to be looking up this Veldspar on either one of these 4 rows to figure out which one is Veldspar, and it's this one. And then we want to spit out the corresponding number here. And so all this is equals index. And we're taking an array, so we're just grabbing this entire array here. But we want to keep this static because this is the lookup array that we want to use. Row num, so essentially this is row 1. As we drag down, we want to increment. So the easiest way I can just do that is just use a row reference to A1. But essentially, I just want this to increase from row 1 to row 2 to row 3 as I kind of copy the formula down. And then we want to match up this lookup value with the lookup array. And this lookup array needs to be static. This will change, this will change that. So, I think I forgot an extra parentheses. Okay. So missing something. Let me try making it an exact match. That's it. That's the difference here. So one of the things on the match is it needs to be an exact match so that the Veldspar matches with the Veldspar. So we can see Veldspar corresponds to 5. That's correct. Scordite should be corresponding to a 4. Nice. And then item 6 is Kernite, which is 2. 2. 5 and 6 are Kernite. Awesome. So it seems like this formula works. And we're going to just drag this down. And essentially what this returns is the mining skills of each of these asteroids for this player. Now, why that's important is because we need to kind of grab the amount that can be total units of ore that can be mined from each of these asteroids. So remember, we kind of already have this, right? We have the total units. Normally, it would just be an X lookup of this value, and then that, and then this times 100, right? Or times 1000. We're gonna, once again, correctly reference these things. So ideally, this is the total amount of units of ore that can be mined. However, remember, we need to take into account the mining skill and the waste. And it's really easy because everything's already neatly arranged. So all we need to do is, if this is a 0, you get 0.75 amount of it. If it's a 1, you get 0.75 plus 0.05. And so the formula essentially to account for waste is just times 0.75 plus this value times 0.05. And essentially, it just means that we'll see, for example, number 2 go down accordingly because it doesn't have a full 5 for mining. And so this essentially lets us know the total amounts of units of the asteroid that we can actually mine here. Okay, so now this next step here is the mining barge. Remember, for the mining barge, we can only store up to 27,500 cubic meters of space, right? So let's convert all of this into total storage in cubic meters from the asteroid, right? And this, once again, should be pretty simple because given an asteroid type, we can look up its storage. So Veldspar has a storage of 0.01 and so forth, right? So what we can do is we can just equals this value divided by, or multiplied by, and then we want to do an X lookup on this. And then just this storage meters cubed reference. So we want these to be same, except this needs to be static. This needs to be static. Cool. And so this essentially lets us know how much storage space it takes to store all of these minerals. And then now we need to get barge. How much the barge can contain. And the max is, I think, I need to look this up, 27,500. So 27,500. So that's how much the barge can contain, right? And so the easiest way we can identify the mining kind of capacity total is, let's just imagine if a barge kind of collects all of this in order, right? So at the first asteroid, it'll have 600. At the second asteroid, it'll have a sum of 600 plus the 142. So we're just going to do a sum of this with itself. And we'll keep the first term static. So now as we drag this across, we can see that we're adding up all of the kind of values as the barge goes across the 10 containers. And essentially what we want to be aware of is when a barge collects more than 2750, we want to be smart about how much the barge actually picks up here, right? So essentially what it is a final units mined total. And we don't want the final storage because it's just easier to convert units mined into minerals mined. So what we want is final units mined across these 10 asteroids. And essentially what we want to do is we want to do a smart kind of way of, let's take a look at this how much the barge contains, right? So if it contains less than the 27,500, we're just gonna pull the amount of storage because then we'll convert it to the amount of units mined. So if equals if this is less than or equal to this static mining barge capacity, then we're just going to pull this value, right? So now what happens if this is more than the barge capacity, right? So if this is more, let's take a look at the previous term. If the previous term is also more or greater than or equal to the barge capacity, then we just simply return 0. We're not mining anything because the barge is already full from its previous kind of asteroid that it mined, right? However, if it's not full from the previous asteroid that it mined, then we want to grab the difference in amount in storage that it can get. So if it's false, then we want to grab this. So it's total max capacity subtracted by whatever the capacity it could have hold here. And I think this should give us a good idea of total mining. So for example, it mines everything for these. And specifically, I just want to take a look here. Yeah, right? So once it goes beyond the 27,500, we only mine amount up to the 27,500. So technically all of these values should be less than 27,500. Okay, so this is nice. And this formula works. However, what we need to do now is we need to convert this back to the total units of ore mined. So we want to do another X lookup for the asteroid. And just divide it by the storage space. And that should relatively easily get us back to the units mined. Cool. So now we have a total number of units mined for a series of asteroids. Now we need to pull the total number of ore from asteroids, right? And once again, let's just grab the 4 ore types that we have or that we need. And if we take a look at what our previous formula is, what we essentially end up doing is we just did a lookup for kind of the asteroid and how many titanium in that asteroid and stuff. Now, though, we have kind of a little bit more complex of a calculation because we have all of these. So imagine like we need to do that same formula with this one, same formula with this one, same formula with this one, and we need to essentially add it up, right? And the easiest way, once again, is to use a sum product formula here. And we want definitely kind of this array to be what we look up or what we multiply. But what is the second array that we need to multiply, right? Essentially, we need to multiply the 600 by kind of whichever asteroid it is for the tritanium. So for example, if we have the C6 asteroid, or for example, if we know that it's a Veldspar asteroid, we want to multiply it by the tritanium amount. However, if it's a Kernite or C9 asteroid, we want to multiply it by that essentially tritanium amount. So essentially what we want is an XLOOKUP of just this list of mining sequence asteroids. And then we want to look up this asteroid location, and we want to return the amount of tritanium that we get from that asteroid. And we want to keep this dynamic just so when we drag it across, we grab the pyrite, mexilon, and isogen values as well. We want everything else to be the columns to be static at least. And then we want the sum products of the columns to be static as well, I think. Do we want any of the rows to be XLOOKUP? I think this should work. Oh, once again, I missed a parentheses at the end. So this should correspond with however much tritanium we mine from any of these asteroids across. And then we need pyrite, mexilon, and isogen values. And I think this just gives us the total amount mined. So fingers crossed. Once again, we need to get the prices. So once we get to this point, it's essentially the same as this part right here. So honestly, we can just copy and paste the dates. Price of minerals. And we just drag this down. Oh, I forgot. When you drag it down for the date, you need to hold Control so that the date stays the same. Otherwise, it's going to try to increment by 1. And then total value. Some product. Once again, we just take these prices and we multiply it by that. 566 rounded up to 567. Looks good. I think that's what the correct answer is. We just need to convert this once again to millions. So final answer equals round this divided by 1 million, 0. So 567, that's very promising. And when we drag it all down, we should be able to just copy and paste these answers across. And all correct. So we are done with case 5, 840. On to our last case for this video, case 6. So now the same players are trying to optimize their mining strategy. Okay, so we don't have any mines here, but we do have mining skills. And so essentially what we're going to have is each player has a barge here, and they're going to try to mine this entire field in the most optimal way. And they select asteroids based off of the following: highest ISK to M3 value. So note, this will be the same for all asteroids of the same type. And then the largest size of an asteroid. And then they'll mine until their barges are full. Okay. So essentially, what we need now is we have a list of all of our asteroids in the location and their types, but we don't know what order that the players will want to mine the asteroids in, right? Because the order of the asteroids is going to be affected by the value of kind of the minerals within that asteroid. The one thing to note here, though, is all of the players are going to mine all of the asteroids in exactly the same order because the map is the same and the rank for kind of the highest ISK to M3 value and the size of the asteroid are all the same. They're consistent. So the only difference really is how much of each asteroid the players can bring back based off of their mining skill. Um, and so knowing that all of the asteroids that's going to be traversed is essentially the same, what we need is the list of asteroids that the players are going to traverse, right? And that's based off of the asteroid, what is it, the ISK? So the value to area that it costs to bring back. And so what we can do and what we need here is we need to figure out the value of each asteroid, each unit of asteroid, right? Yeah, per M3. So what we need in our reference table, and we're gonna add a couple a bit more spaces, is we need a date, and we need to pull the date of the mineral prices as of November 27th, right? November 27th. Okay. So 11/27, 2023. Whoops. Once again, I need to make sure that stays the same. And then we need the price. So we need just the titanium all the way to isogen price. And once again, we'll just copy the formulas that we have used here. Cool. So here is the price. So let's pull the value of each asteroid, which is just the sum product. Okay. So now that we have the value of the asteroids, what we need is the value divided by meters cubed. So then we divide it by this. Okay, so now we get the actual values for kind of these four asteroids. And we want to rank them. So essentially, this one is the most important. So the easiest way I can think of is so not only do we need to rank them by the ISK to area contained value, but we also need to rank them according to the size of the asteroid. So it's actually easier if I just give them a rank and then am able to add in the value of the asteroid itself. And so that way it gives us a nice way to rank all of the asteroids all at once, no matter what kind of the type of the asteroid is. So what we're going to do is we're going to rank this as 1,100 10, and 1. Okay? And so now what we can do is, given these asteroids, we can give a rank. So what we can do is we can use the lookup for this in order to grab the Veldspar. That's the rank. If it doesn't find an asteroid, it'll just be 0. And then we add to that the asteroid count. Cool. So what essentially the 16 tells us is that the Veldspar has 16. So if you have a similar Veldspar that's 5 or 4, it's going to be ranked 14. And so this way, we can just do a really, really easy kind of sort by asteroid and the rank. So essentially what we want to do is we want to paste these as values, paste the asteroid locations as values, get rid of these two, and then just based off of this, sort by rank from highest to smallest. Cool. And I think this should get us the correct order at which the asteroids will be mined, because these are going to be the most valuable asteroids and the biggest size for the most valuable asteroids all the way down to the smallest asteroids. And so what we can do here is we're going to just transpose this. So this is a nice long list of 24 asteroids that we're potentially mining. But essentially, it will kind of just be a reference to pretty much all of the asteroids. I'm actually going to paste this in this in-between column here, and then just do a reference here just in case I'm curious and potentially need to use that. But that will be our mining order. And so what we essentially want to do is we want to do the same thing, essentially like our mining sequence here, right? Except now we just have 24 asteroids. We want to figure out the asteroid type, which is technically all going to be the same, but it's just easier to use a lookup table to populate. Use the asteroid mining skill, total ores mined, and then figure out kind of the total ore that you can mine. So all of this, and this is why doing level 5 is important, because all of this is going to be very much repetition from level 5. So let's grab the asteroid. So keep that static. Grab this, and then go like this, make these static fields. And this should just populate each of the asteroid types in our mining order. I don't know, we need to go to 278. Cool. And the right off the bat, it has a lot of promise because we know that we're mining all of the Ombers first, then the Kernites, then the Veldspars, then the Scordites, based off of the kind of the criteria on how it's mining. So now that we have all of these, the asteroids that we're going to mine, we're going to calculate the second part of it, which is the asteroid mining skill. And then we're just going to copy all of this across. And we're going to just essentially reuse this formula. It might be a little bit different because we need to change the index. So the index here needs to be this. And then we go with row A1, and then we match. What do we match? We want to match this with this. Cool. So that should be 0. Ambar has 0 mining skill. That's correct. And as we kind of drag it across, we get 2, 5, and then 4. So Kernite should be 2, Feldspar is 5, and Scordite is 4. Awesome. We got our mining skills to account for the waste. I forgot how far we need to drag it down. 278. All right. So now we got a list of our mining skills here. Let's kind of figure out what our mining waste is then, or the total number of units mined from each asteroid. And once again, we will copy this list down and we'll reuse the formula here. So essentially, we look up this. Actually, we can just look up because this is the asteroid itself. So it's actually gonna be really nice because it's just gonna be the same. Except the waste value is going to be different. Okay. So here's one thing I like to do. Let's not account for the waste for now. Let's just see if this formula makes sense as we drag it across. So, yep, this looks like it makes a lot of sense, and all of these asteroids are the same. 4. So now we re-add in the waste, and this should really kind of change all of these values. There we go. Okay, then we need to kind of change them into storage, right? Now that I think about it, why don't I just do it all at the same time? Because essentially, and then in order to turn it into storage, we just multiply it by the VLOOKUP, right? Or XLOOKUP of it's all the same. So I kind of wish here it shouldn't really make a matter that much. So we XLOOKUP this, 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 and we get total units of storage. Okay, now that we got the total units, total storage of ore mined. Now remember how we did the barge portion of it? We're gonna do exactly the same thing here. So we're gonna copy. Oh, paste. And we're gonna essentially do some. And we're gonna drag this across. And now we can see very clearly we're gonna be running over the mining capacity of the barge. So now we go to grab the total or the final units mined, and we utilize pretty much that same logic that we did previously. So paste, and then we go if this is less than or equal to this, we're going to grab this much capacity. False. So let me make sure this is static. If false, if the previous amount is greater than or equal to this, then we just return 0. And then if false, we just return this minus the previous amount. And then once again, we need to convert this back to the units. So we just divide by an X lookup for the particular type of ore. There, there, and make this static. Another parentheses. Cool. There we go. And we should be able to utilize that to get the final units mined. Oh. The parentheses was added to the wrong place. Can't always rely on Excel to fix formulas for you. And as we drag this down, we can see that like not all asteroids are mined. And once it kind of gets past capacity, it just mines. Generally, most players mine asteroid 8, and then some mine 9, and one player mine the 10th asteroid. But so essentially, this table gets us the final units of asteroids mined. And then once again, we have the total ore units, right? We could grab total ore mined. And now, thankfully, we don't have to go through all of that. And we just kind of also am able to reuse a bunch of the code that we used before. So some product. This, and then X lookup. We have these asteroids. Oh, wait, we don't even need to do that. we need to just grab the actual asteroids. And then we look the asteroids, and then the tritanium. So essentially what we did for level we want to keep all of this static, I think. Keep that. Yeah, looks right. So we don't mine any tritanium because tritanium is part of the ore that is the least valuable. So essentially, if we just drag this down, we get something like this is the total amount of ore mined, and then date. Once again, we have 11/27, 23, and we're gonna just copy the date or the cost price. Here it is. We use that formula. And now we can grab the total value of everything that you can mine. Cool. Unfortunately, we are only 90% of the way done here. So now the second part of this question says that when a player travels between cells on an asteroid, it costs 1 million per cell. And so what also might have stuck a lot of people is they don't really define traveling between cells super easily. But essentially, according to what I've uh, my experience solving this case, moving across cells means moving to any of the 8 cells surrounding a cell. So you can move diagonally because the answer changes if you cannot move diagonally to a cell. But having said that, you can move diagonally to a cell. And so the easiest way to figure out the distance it costs to move from a cell to another cell is just taking the essentially the row difference and the column difference and figuring out what the max is, right? So for example, if between cells 3 and 4, it's going 1, 2, 3, 4 down and 1, 2, 3 across. You want to take 4 as the distance because you can always move diagonally. And most of the time, you aren't really blocked. And if we do run into some issues, we can just recalculate the distance if there is an answer that is a little bit off somehow, right? Essentially the best way, like when I did it on the spot, I just manually calculated kind of going from the start point of the barge to uh 4, then to to 5, then to 4, then to 3, then to 2, then to 1, then to 5, or whatever the next asteroid cell is. But what I'm wondering though is if there's an easy way, because technically we have the direction of the cells, right? So if we put this into kind of the order, and we actually start on F10, right? Yeah. So we have this order of cells. I wonder if we could use that as like kind of a way to figure out the row and this column. So row distance and column distance. So for example, what I need to pull is just like row I need to refer to this as a cell. So row indirect. F10. Perfect. So that's the formula that we need in order to pull the row here. Essentially, we're just turning this into coordinates, right? So this would just be equal to column indirect F10. So column 6. So change delta, row delta, column. We don't care about the first one, so is equal to absolute value of this minus this. Just drag this down, and then max equals max of these two numbers. Okay, so let me just double check to see if this is right. So going from F10 to H9, we have a distance of 2, 1, 2 diagonally. So H9 to F16, I have 7. So 1, 2, 3, 4, 5, 6, 7. So this looks very promising, and hopefully it's going to help us get to the distance of all of the asteroids pretty accurately. So now what we need to do is we don't have a distance here. We need to kind of put that here so we can refer to it. And then finally, what we have is we just need to calculate the distance that it takes, or the millions of ISK it takes to go to each of these asteroids. So we're just going to copy this. And then distance traveled. And we're just going to say equals x lookup, this value, this, promise we are almost there. So we just go there. So now we can calculate that. But we also need to factor in the fact that if we don't mine anything, so if this is a 0, we don't want to factor in that distance. So equals if that equals 0, 0. Otherwise, do the X lookup here. So that way we don't account for any of the asteroids that we don't actually travel to. So drag this down. Oh, I clearly need to. Yeah, sorry, this needs to be static. That's the importance of static versus. There we go. So now we can calculate the total distance traveled. Which is just the sum of this entire row. And because this is millions and this needs to be millions, what we can just end up doing is we'll just do final answer. Is just equal to the price, total value, divide by 1 million. Take this whole thing and subtract it by this million in terms of distance traveled, and then round this whole thing. So that gets 1365. Yeah, 1365. Awesome. And so that is essentially how we calculate the path of the mining barges and how much minerals that it can mine. And we plug this in. And we get case 6 done. 1080 points. Tune in next time for part 3, where we'll go through how to solve level 7, which is essentially, in some sense, I feel like it's actually easier than level 6 because we have all of the asteroids and we just need to figure out how many ships we can build with these asteroids. So, hope this has been helpful, and no, it's been pretty long, but thank you for staying with us, and check out part 3 when it comes up. Take care. Have a great day. Bye.